We are on day 3 working on the Honda EM600 generator that I got for free from Bridget's dad. Run in 5 or 6 years. In the last part, which I filmed a couple of days ago, we got the generator running, not by any thanks to me, because I had this big plan for pulling the carburetor float bowl and pulling the fuel line and checking the spark, and in the end I threw that all out the window because I didn't have the proper tools to remove the bolts to take the rear panel off the body of the generator, the skin, so I could get full access to the carburetor. So I said YOLO to the whole thing. I put $1 of 91 octane gas in it to mix in with the old gas, 5-6-year-old gas that was already in the tank. And I just took it to Mom's house and I pulled the cord. First pull, thing fires up, runs perfect. And I am so happy about that. Just runs friggin' perfect, and everything on the engine side of things seems to work fine. The throttle control works, it idles nicely, it's nice and quiet. It doesn't hunt or anything like that. It runs perfect, which is really surprising for having a mixture of old gas in it. And you know, I was afraid the carburetor would be gunked up. Nope, she was raring to go. But that leads us to our next issue. The generator makes no electric power, and so that's what I'm going to investigate today and see if I can get the generator making power again. Now, I have an idea that I hope will work. I have a lot of hope that this might be the issue. I'll be disappointed if it's not, but we'll just go from there if it is. So I read something. I read that a common reason that generators will stop making electric power, which usually happens after the generator's been sitting a while. This is something I actually learned in university. It's kind of a neat concept to learn about. So generators, based on, you know, a brushed motor or a brushed generator, a brushed rotating machine for generics, for use of a generic term. They have what's called residual magnetism, which is natural magnetism built into the body of the generator. Without this magnetism, the generator, you can spin the generator, but it won't make any power because, you know, to make power, you need a magnet, you need a coil spinning throughout a magnetic field. And once the generator begins generating power, that magnetic field is generated by the field coil of the generator, so that once the generator begins generating, it's able to sustain itself because there's current flowing through the field winding, which generates a magnetic field, which excites the rotor winding, which gives you electric current. But in an initial state, with the generator not spinning, the field winding has no current going through it. And if you just spin it, the field winding, the spinning alone cannot make the field winding make its own current to excite the rotor winding. So the field winding depends on natural residual magnetism in the generator itself to excite itself enough to cause a runaway effect and make the generator able to generate its own power. Car alternators work in a similar fashion. If I just take an alternator in my hand and I hold it in one hand and I spin the pulley really fast with the other hand, I'm not going to get any power out of it. I'm not going to get any voltage, maybe millivolts, but nothing more. Because for a car alternator to work, to generate electricity, it has to have power fed into it. For an alternator to begin working, it depends on the car's battery to feed it enough current to initialize the magnetic field so that it can begin generating power. So you need a bit of power to begin with in order to generate power. That's how a car alternator works. So you need a 12 volt battery, hooked up to an alternator before it'll generate power, and then you'll get the 13 or 14 or whatever volts out of it. So generators are the same way, except usually you don't need a battery, you don't need that great amount of input, but you need that residual magnetism built into the generator's metal casing. If a generator sits too long, the natural residual magnetism degrades over time, and eventually it becomes too weak for the field winding to self-excite. So to remedy this, we've got to jumpstart the field winding. If we can jumpstart the field winding, the generator will become operational again, and by being operational again, it'll rebuild that residual magnetism in the casing, hopefully. So we need to do this by feeding power into the generator. And a popular way to do this is to take an AC powered drill and plug it into the generator while the engine's running, and then twist the drill by hand. An AC powered drill has a universal motor. Anything with a universal motor can do this, because universal motors can function as generators when spun manually. So it could be a drill, angle grinder, whatever. Vacuum cleaner motor if you have one lying around that you can spin by hand. Plug it in, spin it by hand, and the current generated, I'm going to be using a drill for my test of this, and if it works, the current being generated by your manually spinning the universal motor will excite the field enough that it'll jumpstart it and the generator will begin making power. So that's what I'm going to try when I get to Mom's house. She has an AC powered drill. I brought my battery powered drill, which Bridget's dad also gave me for Christmas, a brand new Ryobi powered drill. It's their little 12 volt model, and I love it. It's very, very nice. So I brought that with me, so if spinning Mom's drill by hand doesn't work, I will try connecting my drill to Mom's drill and using my drill to spin Mom's drill. And if cranking it by hand doesn't get it going, maybe spinning it faster, more constantly with my drill will do it. If a lack of residual magnetism is indeed the issue, this will hopefully get the generator making power again. If it doesn't work, then there's something else going on, and I'll have to investigate further. But my fingers are going to be crossed. I'm going to be cautiously optimistic that this will work. But we'll find out and hope for the best. I decided to begin by seeing how well the generator would cold start, having not run in a couple of days, with the throttle control turned all the way down. Beautiful. That 4-stroke 60cc engine really does run amazingly well. That clattering you hear is just something vibrating. It only seems to happen when the engine's running at low speed. So now all there is to do is plug in the drill, hold the trigger down on the drill, and start cranking on the chuck and see if it comes back to life. Well, clearly this is going nowhere. I'm starting to get a little worried at this point, but I brought my cordless drill for a reason, so let's connect that up to the AC powered drill and see how that works. I'm beginning to lose hope, as something definitely should have happened by now. But I'll try something else. Maybe the engine's just running way too slowly, so I'll crank the engine speed up and see if that helps us out. At this point, I'm bummed and about to give up and shut the generator down. Until suddenly, yes! Yes! Oh, that is awesome. Success! I decided to go back and restart the generator and see if enough residual magnetism has built up already that it can start making power again on its own. Excellent. So the generator seems to be working perfectly now, which is so awesome. So the next step is, I've got my kilowatt meter. I've also got a load, my incandescent light bulb load, which I added a second light bulb to, a 300 watt light bulb. So I now have 450 watts of incandescent lighting as a test load, which is a pretty good test load. It should be a pretty good shakedown test for the generator. But first I'm just going to plug in my kilowatt meter and just play around with it, see what voltage and frequency we have, see how that changes when I play with the throttle control, stuff like that. So you can begin to see how loosely regulated these older generators were compared to the generators we have today that have really precise electronic governors that keep the engine running at the perfect speed to get 60 hertz. They automatically immediately readjust when the load changes and stuff like that. No, not this generator from the 80s. The engine speed sort of wanders. You can't get it exactly at 60 hertz. If you're lucky, you'll get it to wander between like 59.8 and 60.2. And you can see that while the open circuit voltage was like 115 volts, once I apply that 450 watt load, which isn't even fully stressing the generator, the frequency dropped to below 55 hertz and the voltage dropped down to just 107, 108 volts. So you can see just how less precise these generators were. That's why they give you a throttle control on the side, because you have to constantly readjust the speed whenever the load changes or anything like that. That's just the way it was with these generators. I personally think it's kind of fun to have to readjust the engine speed to maintain the proper frequency, but clearly it was less convenient back then as it is with the generators of today. So the next few minutes is just me playing with the generator, having some fun, taking readings on the kilowatt meter, stuff like that. So I'll do a bit more commentary here. You know, in educating myself for this generator, part of what I did was watch some YouTube videos, and I found some annoying common misconceptions that people seem to have working on these vintage generators. The biggest one I find is that everybody adjusts the engine speed to achieve 120 volts or 115 volts, whatever they're trying to achieve. They think they need to adjust the engine speed to match the proper voltage. No, you need to adjust the engine speed to match 60 hertz or 50 hertz if you're in a country that uses 50 hertz power. Keep the engine speed running for the proper frequency. Don't worry about the voltage, because as you can see on a generator like this with my 450 watt load, if I were to try to adjust it to meet 120 volts, it would be running at 70-75 hertz. Now for incandescent light bulbs, that's obviously fine, but you know, you wouldn't want to do that for like a magnetically ballasted fluorescent lamp, for example, something that's going to be sensitive to the frequency. Always adjust for the frequency, not for the voltage. It annoys me how many people get this wrong. The acceptable range of mains voltage here in North America is from 105 to 135 volts. So this generator, even though it's only putting like 106, 107 volts with how I have it set, it's within the acceptable range, and 99% of electrical and electronic equipment is gonna run fine at that voltage. There's nothing wrong with it. So yeah, the frequency is what's important, not the voltage. Don't worry about the voltage sagging under load. There's nothing wrong with that. The second misconception I saw, and I've only seen this one voiced by one or two people, they're saying don't run high-tech stuff like computers or modern TV sets or stuff like that. They're like, don't run high-tech stuff on these vintage generators because the sloppy voltage and frequency regulation will end up destroying them. No, that also could not be further from the truth. Modern electronic devices have switching power supplies that are literally designed to handle whatever voltage and frequency you shove into them. Everything now has a world power supply that's good for 50 or 60 hertz, from 100 volts to 250 volts. So you would have to try very hard to make this generator produce an output that would cause a device like that to screw up. There is nothing wrong with running a computer, TV, anything with a modern switching power supply on this generator. It's simply not going to hurt anything. If anything, they're going to have an easier time running on this than running on an inverter, for example, that produces a modified sine wave output. This generator, a true mechanical generator, produces a true sine wave output, and that's really nice. So no, there's definitely nothing wrong with running your high-tech stuff on a generator like this. It's simply not going to hurt anything. And that's it for this part of our saga with the Honda EM600 generator from the 1980s. I am so happy that the generator works fine. It just lost its residual magnetism. It's funny because I initially, even though I should have known because I learned this stuff in university, I initially did not even know that this might have been a thing. And when I, was reading about what causes generators to not produce power, and I saw this thing about, the residual magnetism loss and the drill trick with re-exciting the field winding, I thought, oh my goodness, wouldn't that be awesome if that was the case for me? And it was, and I'm super happy about that. It really didn't want to come back to life. I don't think it ever would have had I just kept doing it by hand, so I'm really glad I brought my drill with me. Even then, it took a lot of spinning. Like, when I watch people on YouTube do this with their generators, it's usually like one or two flicks of the wrist and the generator's working again. But for me, I had to spend like a minute or two just wailing on the AC drill with my own drill. I was really surprised, and I almost gave up. I figured there must be something else wrong, but I'm really glad that that wasn't the case. And we'll see. Hopefully, now that I've done that, if I were to let it sit long enough, it would lose the residual magnetism again. Hopefully that doesn't happen to me. Hopefully I run the generator often enough that it doesn't do that. However, if it does do it again, I know how to fix it now. So yeah, I'm really, really happy. You may notice in the last clip, I was banging the front panel there. The pilot light doesn't work, and I don't know why. Either the bulb must be burned out, or there must be a wiring issue. Or is it possible that like the generator has multiple rotor windings for different purposes, and the winding that powers the pilot light isn't working? I don't know. But yeah, the pilot light's not working. I'm gonna have to figure out how to remove how to get access to the electrical panel assembly and pull the bulb and see if that's any good. Or maybe it would be easier to start just with a multimeter, probe where the bulb electrically connects, make sure there's actually voltage there. According to what I read, it should be a 6-volt bulb, just like the oil indicator light, which is also a 6-volt bulb. The oil indicator light works just fine, so maybe the pilot light really is just burned out, but I'll find out later. So yeah, super duper happy. So I don't have a concrete plan for what to do next. I've actually already filmed some stuff that will be in the next part. Mom does have a proper socket set with imperial and metric sockets, so I was able to finally take all the decorative cladding off the generator, get full access to the internals. So I do a little bit of cleaning. I open up the air filter for the carburetor because for some reason I never thought to open that and see what the condition of that was in. Take a look at the oil, see what that looks like, and then I'll probably do some more stuff which I haven't filmed yet. But that's the case so far. In the next part I might play around with it. I might start getting a little bit experimental because idle is like 2300 RPM. I'd like to see if I can turn down the idle speed to something slower than 2300 RPM. I like the concept of being able to start the generator really gently when it's cold rather than having it rev up. I think the first time I ever started it after 5-6 years, it revved up to like 3000 or 4000 RPM, which definitely isn't very nice for it when it's been sitting that long. But yeah, just for fun, I'd like to see if I can turn the idle speed down a little bit more. And yeah, so stuff to come in the next part. I am enjoying this generator, working on this generator so friggin' much. My first time working on a small engine, the first small engine I've ever owned, and it's a generator, which makes it twice as awesome because obviously I'm into electrical stuff. And yeah, really happy. Maybe a little too happy, but I don't care. I'm just over the moon with this thing. It's really fun working on it and getting it back to life after sitting for so long. I really love it. So that's it for this part. I really hope you enjoyed, and I'll see you in the next video.